Miss Collier explains.
Area of a parallelogram.
Our learning intentions are to understand that the area of a parallelogram is related to the area of a rectangle, and to be able to find the area of a parallelogram when the base and height is given. We will know we are successful when we can find the area of parallelograms. Today we're going to look at finding the area of a parallelogram. Let's start with talking about what is a parallelogram, because I don't think it's a shape that we really talk about all that much. I have a picture of one here, and we're going to go through the definition to really help you understand what a parallelogram is. Okay, so let's read it together. A parallelogram is a four-sided shape. So that's our first step we need to note. It's four-sided. It has two pairs of parallel sides. Okay, so we have two sides that are parallel to each other. So far, that's very much like a square or a rectangle. Okay, four sides and they're parallel. That means the opposite sides would never touch even if they continued forever, just like a square or a rectangle. The pairs of parallel sides are marked by arrows. So you know how sometimes we have little lines on shapes? There's like one line and then over here one line, and that means that the sides are of equal length. Well, if they have little arrows on them, it means that the lines are parallel to each other. So on a square and a rectangle, we assume that the lines are parallel to each other because if they're at right angles, they have to be parallel. But on a parallelogram, it will be drawn on with little arrows to show you that those two lines are parallel to each other. And I'm guessing you've picked up that a parallelogram gets its name from parallel. I hope you figured that one out. Often on a parallelogram, it will have the base, which is noted as B, and the height, which is noted as H, marked out. Now the height is the perpendicular height. That means the height from the bottom of the shape to the top of the shape. It doesn't mean this length here. If you know anything about hypotenuses and triangles, you'll know that the hypotenuse, the side on the angle, is actually longer than the height of the shape. So when we're looking at the area of parallelograms, we are not actually looking at that length of the side, but rather the perpendicular height of the shape. And you'll see why in a moment. If you can remember, perpendicular means at right angles to, okay? And that's shown with the little square that shows a right angle. So the height we're looking at is the perpendicular height. So the height that is at right angles to the base. Another tip I want to give you when you're looking at a parallelogram is that base doesn't necessarily mean it's on the bottom. If a parallelogram was like on an angle, the base might look like it's coming up the side, but it's considered the base of the shape because it's not at an angle. And then the perpendicular height comes off of that base at 90 degrees. To me, a parallelogram reminds me of a rectangle that's been pushed and it's leaning over. And we'll see in a moment how we can sort of relate that to help us remember the formula for a parallelogram. Let's look at parallelograms in everyday life. Whenever pairs of parallel straight lines meet, a parallelogram is formed. As we can see in this photo, this includes train tracks. Train tracks we know are parallel because if they weren't, the train would smush in on itself or try and stretch itself out, but it doesn't. They're always parallel. So as we can see, when the train tracks cross each other, they create parallelograms inside their tracks. How are we going to find the area of a parallelogram? Like I said before, I see a parallelogram as a little rectangle that's had a little shove. It's had a little push. It's leaning on its side. So if we look at my measurements here of my parallelogram, we can kind of see that. We can see that the one side of the push is the same as the other side of the push, just sort of upside down. So let me pretend that I've got some digital scissors and I'm going to snip the one side of my parallelogram and move it to the other side. Let's see what would happen. Here we go. I've gone snip, 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 and I've moved it to the other side. And what can we see? I formed a rectangle. I put the rectangle back together. So that's going to be super helpful to us when we're thinking about how to find the formula for a parallelogram. I'm going to show you that little snip snip again digitally. Look at this. I'm taking it from one side and I'm moving it to the other side. And we can see then it forms that rectangle again. So then let's think about it. Let's remember the formula for the area of a rectangle. The area was length times width. So we now know that a parallelogram takes up the same amount of space as a rectangle, just in an odd sort of way. We can use this understanding to generate our own formula for a parallelogram. We just have to find out where the length and width is within a parallelogram. So let's think of the length. We know on a parallelogram, the base is given to us. And on this parallelogram, the base is 10 centimeters. What we also know, if we cut this side and move it to the other side, that's like a length. So the base is actually the same distance as our length would be when it's turned back into a rectangle. So for a parallelogram, we're not going to write length, but we're going to write base. Next, we need to know the width, which usually goes up this side of our shape. But as I said before, this side of our shape is actually longer. And if we looked at that length right here, we would see that that has no relation to our formula for the rectangle. Instead, what does relate is this side right here, which is called the height in a parallelogram. So this height right here, this perpendicular height, is the same as the width in a rectangle. So instead of writing a W in our formula, we can write H, which represents height. So now we can see that our formula is almost the same as a rectangle, but we don't want to use the same formula because length and width might confuse us, because a parallelogram doesn't really have a length and a width. But we can use our understanding of our formulas to realize that a parallelogram does have a base, which is the same distance that its length would be, and it does have a perpendicular height, which would be the same as the width. So our formula for a parallelogram is area equals B times H. We can see our formula here. And don't forget my reminders of making sure you're using the perpendicular height, not the side, because they might put in the side length to trick you. And to remember that your base is not necessarily on the bottom, but it should be connected to your perpendicular height. Let's have a go at finding the area of parallelograms. Find the area of these parallelograms. A. So we have a parallelogram here, and first I'm going to write the formula, which is area equals base times height. Now I need to substitute my pronumerals with their values. The base of this parallelogram here is 12 meters, and the height, I'm looking at the perpendicular height, is 5. 12 times 5 is 60, and now I'm going to put in my units, which is square meters. B. First I write the formula. Area equals base times height. Now, this is one of the tricky parallelograms I told you about, because you can see the base isn't flat on the bottom. So we have to find the flat surface that has a measurement, which here is actually up the side. You see we have a flat side with a measurement. So that is actually our base. So our base here is 2. Now, the height should be perpendicular to the base. And what you'll notice on this one is they haven't put the perpendicular height inside the shape, but they've actually put it outside. They've drawn this line here to represent that this is coming straight out, and then the 3 centimeters is at a perpendicular height to that line, which means that 3 is the perpendicular height. So I've replaced my H with a 3. Now I can multiply. 2 times 3 is 6. And of course we need to look at our units, which is centimeters, square centimeters. Now you try to find the area of these parallelograms. Let's check your answers. First, I write the formula. Area equals base times height. My base here, again, is on the top of the shape, but I know it's a base because it's a straight line with a measurement. So my base is 6. And then my perpendicular height, which I can see by the little 90-degree symbol, is 2.5 meters. I'm allowed to use my calculator to figure out the area, but I'm going to try to do it in my head. 6 times 2 is 12, and then 6 times a half is 3, and 12 plus 3 is 15. So 15, and it's square meters. B. Formula first, area equals base times height, then substitute. My base here is on the bottom, look at that, 3 centimeters. And my perpendicular height is outside the shape, but that's okay, and it's 6. 3 times 6 is 18, and it's square centimeters. How'd you go? I hope now you can find the area of parallelograms.